Thank you for joining us for Making Computational Methods Accessible, Data Visualization, and Teaching Computational Social Science with Jae Kim, Ph.D.
Okay, and then share the my screen. Can everybody see the screen? If you can see it, then please type 1 or yes, or you can just nod your head. That's quite fine. So we are the second day of the, I don't want to call it iBootcamp because there's already iBootcamp. So it's the same. So to me, it's kind of more complementary. So I think Chris Harris teaching, so you guys might take his course, amazing class about art. So you guys can be prepared for taking more debating sessions throughout the SICSS. And my idea here is sharing my experience about learning and teaching art so that you can learn the stuff that Chris teaching more easily and quickly. So yesterday, what I covered is kind of basic art. So how you can install art, how you can set up it, and then some fundamental things that you want to understand about art, like objects, environment, functions, documentation, sessions, all those kind of things. So you have learning to these terms lots of times when you are using art, but you might wonder what exactly they mean. So the goal yesterday was trying to demystify these terms and breaking them down so that it becomes more accessible and more intuitive to you guys. And today the goal is talking about tidyverse. So I think my impression is maybe most of you guys have heard about tidyverse. So if you have heard tidyverse or used it, then please type 1, or just again nod your head. Okay, most of you. So for those people who know and who use their tidyverse, what is tidyverse? And what do you like it or what you don't like it? Can anyone volunteer to share your opinion about it?
Can go. It's like a package. It's like a package repository that a group of R developers created for people to learn it easier. And I remember something about old R users or something from the video.
Yeah, it's sort of like a collection of the packages. So if you remember what I talk about, so Nico said also, yeah, so remember an example using tidyverse in the bootcamp. So if I kind of refresh your memory, package is just a collection of functions, right, written by someone else. And then if you install and then load the package, you can use the functions written by these other people. And tidyverse is a collection of packages. And like Marisa said, one of the very random packages in tidyverse is dplyr. That's for data wrangling. There's another one called the ggplot2. That's for the data visualization. But nowadays, there's also another package called tidymodels. That's for all kinds of modeling, from inferential modeling to prediction modeling. So from data cleaning to data visualization to machine learning, there's a kind of same language, same framework that you can use to do all kinds of things that you want to do just using R. So that's the idea behind tidyverse. And why? So there's a reason why I'm so excited about this tidyverse thing, and why I want to spend some time about why tidyverse is so important or so essential to understand the current landscape or ecosystem of R. So if you think about if you spend some time learning R, both R and Python, there is some kind of difference between R and Python, and there are many. So one difference is it used to be known that Python has more. So if there's a library in Python, it's much bigger and more comprehensive. And if there's some kind of similar package in R, it's kind of much smaller in scale and narrower in scope. But from the perspective, tidyverse is very interesting because it's nearly large project, right? Like I said, it's not only about data cleaning. It's not only about data visualization. It's not only about like, just about data. It's also about model. It's also about communication. It's also about everything. So every step in the data science workflow, you can do that within this giant framework. And the other thing is this is still expanding. So RStudio is spending lots of money and energy and resources to make it better and more accessible and so on. So so that's, I feel, very striking aspect of the tidyverse, and why this is great, because one of the downsides of R is it's just so fragmented and scattered, and then most of the contributors are amateur. So sometimes, so one of them, you say that the difficulty about understanding error message. One of the reason why error message is so difficult to understand in R, because the error message is like, just there's no understanding about professional level software development, and like you trying to understand what's going on here, and it's just there's no idea. I mean, it's very difficult to understand that process behind. But tidyverse is not only comprehensible, but it's also very, very accessible. So it's good for beginners, but also it's good for intermediate users. It's good for professional users at the same time. So it's kind of revolutionizing the way we have used R, we have taught R, so that's why this is so great. So when I first got started in R in 7 years ago, actually 8 years ago at this point, 8 years ago, tidyverse was not that much popular, and it's among the instructors teaching R at the graduate level. And I learned everything in base R. Base R is still important. I sometimes use them, and then I appreciate the training. At the same time, like if you're doing things in tidyverse, it's quicker and easier. It's not only for yourself. If you share the code with other people, the other users also can pick up your code much quickly and easily. So there's lots of good things about tidyverse. And we are getting to what is tidyverse this session. So, okay, so the first thing I'm going to do is, so let me show the procedure. So if you click the URL, then you are here in the repository, GitHub repository. And then if you scroll down, you see setup, and just to click this button. And then you are going to launch RStudio on your web browser. If you done it yesterday, this process is going to be very quick. If you haven't done it yesterday, it might take some time. And don't worry about it if it takes time, because eventually you are going to get there. And then after you open this, there are 4 sections, right? We call panes. Source file, there's a console, there's an environment, and there's a file. And then, okay, project. Yeah. And then we are creating this code, and then you see a bunch of files. And we covered setup and data structure yesterday. So we are going to create this number 303 tidy principles R markdown file. And then you are going to see this. And so everybody remember this Pacman package yesterday? So instead of like install packages and library several times, you can just need to install this one package called Pacman. So Pacman stands for package manager. So that's what pack means package, and man means manager. So like I said, developers and programmers, they love short names for everything. So instead of list, they just call it LS. Do anyone has a question? Okay. Yeah, so again, please feel free to interrupt me if you have any questions. So instead of list, they open your LS list, and instead of remove, they use RM. Yeah, so that's what they do. So so we just need one package called Pacman, package manager. And there's one nice function called pload. So the function finds whether this particular package is installed or not in your machine. And if not, they're going to install it and load it. And same for the other packages. So we are going to install and load a bunch of packages, but the key one is this tidyverse. So tidyverse has lots of functions. One way you can see that is tidyverse, and then columns, and you can see that, wow, there are just there are 7 different ones. It seems like there are not many packages, but actually not, because tidyverse is a package that includes many other packages. So it's kind of wrapper, right? So like there's more complex packages, and then it kind of giving a nice interface for that. So that's tidyverse. It includes packages like dplyr, ggplot2, tidyr, and so on. So so let's first talking about what is a tidy data principle. So there's a reason why this is called tidyverse. So even though there are many packages in the tidyverse framework, the core is this idea, lies in this idea, tidy data. So Heather Wickham, he's the chief scientist over RStudio, and like I said, he's kind of demigod figure in the R community. So everyone knows him, everyone respects him. So because he has contributed so much to the R community, because he's the, like I say, dplyr, ggplot2 was his dissertation project, side project, and then tidyr, dplyr also, those are his inventions. So he got many papers about data work. So here's one of the goals for him is making data work easier and faster and more accessible and so on. So that's the idea behind his research and his professional work. And now he's doing the same thing at a scale at RStudio. So one of the things that he focused on, like when he's developing this package called tidyr, so it's kind of the first of the these many other kind of the foundation for many other packages in the tidyverse, is many people, including graduate students, faculty, data scientists, and so on, spend lots of time just cleaning and rendering data. So I remember around this time last year, I was working on a project about anti-Asian hate crime and using Twitter data and survey data, which is about to be published in a journal. So we are almost doing the final revision. And then when I was working on the project, I spent like 2 weeks just cleaning data and then just 1 day for modeling it. So actually modeling it doesn't take a long time. So modeling one, I mean, even though like you need to spend lots of many hours in the stat course, you need to sit in stat course to learn about the technique and so interpretation and whatnot. But actually, if you do a project, you're gonna spend more time just cleaning, rendering data. I don't know. So I want to ask a question here. So is it my unique experience, or you've got gone through the same experience? So when you're working on a project, I think maybe it's the same for the qualitative people as well. So you've got interviews, scripts, and then you need to actually transcribe it and then like understand the make it clean and so on. So Meredith says yes, same. And to me, it's absolutely same. People don't talk in full sentences yet. Yeah, it's awful. So maybe for the quantitative people, maybe that's missing values. They need to figure out what those values are. Yeah, absolutely whether qual or quant. Yeah, so there's one principle in the word universal law, maybe that's data is messy. It's kind of like, so I watch lots of Disney movies and TV shows these days. It's not because I'm a huge fan of Disney, it's because I have a 3-year-old kid at home. So first maybe we just binge watching Netflix, but then realize that there are lots of TV shows that are not appropriate for my kid to watch. So we just switched it back to Disney and then watched a bunch of shows. And then like the kind of relationship portrayed in the Disney production is very ideal and simple, but I mean it's appropriate for kids, but like in the real world it's very messy. So when I think about my relationship with my parents and my wife, it's not the same thing. So when you are maybe it's not the example, I don't know, but when you are learning stat, because there the focus is theory, right? You need to understand the math behind it. So the kind of data given to you is the toy data is usually very neat and perfect. There's no missing value. Like if you're studying, maybe if you're learning qualitative data, the script is kind of very beautifully written. Everyone's saying like their emotions, their ideas in a very clear way. So when you're reading it, actually you can get the gist of it pretty quickly. But actually when you get out there and then trying to collect data and then see how it looks like, everything is just so messy and ugly. So that's true. And so what Heather becomes up to in tidyversity is, yeah, there are so many mesh data, and that's just real. Then what I can do as a programmer is doing the two things which I explained a little bit yesterday. One is making clear about what should be the output, okay? And then we can talk about different types of messiness. It's kind of typology. And then after we figure that those two things out, then we can come up with some solutions. So you are going to learn lots of things in tidyr and deployer for data wrangling and cleaning kind of stuff. But this is like, if I lay out, these are the three core ideas behind. So think about what's the clear output. You know, like if you're writing a paper, whatever your motivation, intention, whatever method you're using, there should be some kind of layout, right? Where you put your argument into your evidence, you arrange your evidence and things like that. It's the same thing. So even though like no matter how much data you have, in the end, the kind of ideal output you want to have might be that's identical. Okay, so that's first idea. And second idea is maybe you can have some typology about different types of messiness, about different kinds of ugly and mess data. Then we can talk about solutions. So when you are mostly learning or teaching tidyverse, we just focusing on this, the last one, the number 3, and then we didn't talk much about the first and 2, or we covered that nearly quickly. So we didn't have time to sink these ideas into my mind and grasp the intuition. So today I want to talk a little bit more about 1 and 2, because the idea about this session is that it's not exactly, you know, teaching you every detail about tidyverse. It's more about thinking about the big picture and the big ideas behind tidyverse. So one way you can see it. So here's a tidy. Just give me a sec. Yeah, let me show you the web browser version because it's a little bit messy. Yeah, so let's look at this. So the idea behind tidy data is actually pretty simple. So when you have when he talked about, Wickham talked about tidy data, the data is data frame. So we have a fixed number of columns and we have a fixed number of rows, right? So something that looks like this table or spreadsheet. And here the idea is no matter what kind of data you got at the beginning, so the end result should be like, so every column should be, so if you look at the names, they should be variables. The variables that you want in your data. And then if you look at the rows, they should be observations. So if this is the contour level data, if that's the unit, then you should see the contour level observation in these individuals. And then if this is the ideal, if there's match data, something is wrong about whether column or row and so on. So let me give you an example. So if you look at this data, so there's a table for a data frame, right? So this is a table for a data frame. Let me go up. If I do this, you can see that this is data frame. How can I know this is data frame? Because it has 2 dimensions, columns and rows. And then if you look at each vector, so this is integer, and this is character. So there are different types of variables or vectors. So we can know that this is a data frame. And if you think about tidy data principle, which is pretty simple. So columns should be variables, and then rows should be observations. Also think about the unit. Something is wrong about this data frame, table for A. Can anyone notice what is the problem? What is the problem about this particular table? Why is this data not tidy? So if you think about these simple principles, columns should be variables and rows should be observations. Heather believes that this kind of setup is ideal for doing modeling or visualization, whatever next steps you envision yourself to do. Here's so you do want a variable column for year. Here's columns which are observations. It should be year by country. Yeah. So both Maxine and Todd are absolutely right. So the problem is 1999 and 2000. They're actually not variables. They are observations, right? There should be year variable, and these should be observations of that particular variable. So the first problem, so like we talked about the ideas, the first idea, that's the title principle. And then we talk about different kinds of messiness. So one type of the problem is something called reshaping the data frame. So here the idea is either the ranks of the column or the ranks of the row is wrong from the perspective of the ideal tidy data set. So if you get this, we call this as a wide data, too much wide data, because if you think about the ideal data, there should be country and year variable, and it should be longer, not wider. So if you recognize that the problem is it's too much long, too much wide, then how you can make it fixed? Let me put this one just to show you. Let me show this the answer. It's pretty simple. If the problem is too wide, you should make it longer, right? And then if you're an Excel user, you might heard about pivot table. Actually, I've never used it, but when I was teaching, many of my students are coming from the Excel or spreadsheet background, and then they talk a lot about, oh, actually you're talking about pivot table. So that's something I learned from my students. So we need to pivot and then make it longer. And actually there is a function called pivot longer. It's actually from tidy package, pivot longer. And if you type this, you can see there's a yellow box, and it shows what is the arguments you should use. So after data, there's a columns, names too, and then there's a values too. So I'm gonna demonstrate about this later. So don't pay too much attention to about these details and just focusing about this idea. So the first problem you can identify is a shaping problem. So either this dimension is too long, column is too long, or then there's too much wide data. They need to fix it and making it longer. If it's too long, then you need to make it wide. So I'm gonna skip this. And so for those people who already used tidyverse, especially dplyr, probably you have used the gather and spread. Have anyone used this before? Gather and spread functions from dplyr? Yeah, 0 is great, again, because you are doing something new, and then 1 is also great. And have you also know that there's a new function called pivot longer and pivot wider? These functions came up after dplyr was updated to 1.0. Yeah, they are doing exactly the same thing actually. So there are two regions after dplyr 1.0, that's the version name, that dplyr function name changes from, not dplyr, sorry, tidyr function name changes from pivot longer, pivot gather and spread to pivot longer and pivot wider. And I believe that one reason is, again, like I said, many people, especially beginners in R, coming from the Excel or spreadsheet background, and then the IS2 people, they want to make these function names and usages more familiar to their background. So yeah, making their learning journey easier. So that's one reason. And the other one is like, I'm going to show, yeah, it's better, maybe better than just I'm going to show that. So again, this is table 4a. And yeah, just give me a second. I want to change the the arrangement of these panes. So tools, global options, and then pane layout. I'm gonna put the console here because to me it's a little bit annoying. Yeah. So now console is moved here. Okay. So table 4a, this is what it looks like. And then I can use gather. So like many of you pointed out, the problem here is these are observations, not variable. So I'm going to create a one variable called year. And then that's putting these two columns together. And then they have observations, right? And then they are called cases. So actually we are creating two new variables. So one variable is called the year, and then the other variable is called the cases. So year is for the original column names, and then cases are for the values associated with these, all the columns. So here what's going on is these are the columns that you need to bring together, and this is the key so this is the columns and this is key and value. So let me ask a question. When you heard key and value, does that at the interior level, does that make sense to you? Those names are very intuitive or not? It depends on your background actually. How about those names? Are they very intuitive or not very intuitive? Or kind of between, not intuitive? Yeah. So for those people who come from the SQL or database background, key value actually totally makes sense. Because in many databases, key value pair is the key to understand, database structure. And then if you are from Python background, there's a data type called dictionary, and dictionary is exactly about key value pair. But for most of our users, especially if you're coming from the Excel or spreadsheet background, this key value thing just it doesn't make sense. And I told several years, and whenever I'm teaching spread and the getter function, many people struggle with these argument names because they don't make sense to their background. And Tidyverse changed it. So the Tidyverse team decided, okay, if many people complain about this, then actually we are wrong. So we need to fix this problem. So what they changed in this new function is first, put what people might think about first. So, okay, again, look at this table 4a. And so what they asked you to do is first identify the columns you think, okay, sorry, maybe I need to close this. It's kind of messy. Yep, I'm gonna close that one. Let me see. Yeah, I didn't do it wrong. Oh yeah. Okay. Here. Table 4a. It's not. Yeah. Okay. Oh yeah. I did something wrong here. Let me just erase this because at this point it's not. I think I made one mistake somewhere, but I don't know where I made it. Yeah. Oh yeah. Here you go. I kind of figure out. Good. And maybe changing the pane is not a good idea. Sorry for this. Oops. Source. It's gonna be console. Apply. Okay. So look at the table 4a again. What's wrong in my? Sorry, I'm gonna start over. Okay, new project. Don't save. And existing directory. Choose. I'm creating a clean environment and then starting over. Something that I showed you yesterday, and I'm practicing it unfortunately because something happened about this. Okay, I'm going to roll the package again. What is wrong? Yep. If you look, oh yeah, here you go. Fix the error. Now it's good. Yeah, now we're good to go. So going back to table 4a. Okay, so this is what table 4a is looks like. So in the past getter function, the first thing they asked is identifying key, identifying value, and then picking up the columns they think you think that they are wrong, right? And then there are two things wrong. One is about the sequence. I mean, you need to be aware how people thinking about these problems in a sequence. So whether they think about key and value first or these columns first. And then the second problem, it's kind of user interface problem, is whether these key value, whether these names make sense to most people. So what they changed in this people longer function is, what they ask first is columns. Okay, when you're looking at this table 4a, what columns are problematic? And maybe it's easy for you to pick up, okay, it's maybe just 1999, 2000, because these names actually varies not the variables. So you can pick up these columns, and then because you are picking two, you need to use this concatenate, and then this string 1999, 2000, you are selecting columns. And then after you're selecting these column names, you need to give them a variable for that. So you are naming it as year. And these columns have values. And then we are moving these values to another variable called cases. So this is exactly same, right? In terms of the functionality, they are showing exactly same output. But like what they change a little bit is about thinking about this process. So how people can use this function at the more intuitively, given their background and experience. So does this people longer make sense to you? If it makes sense, please type 1. If it doesn't make sense, please type 0. Then I can explain a little bit further. This is just a demonstration, but I'm just trying to show that how trying to be accessible tidy diversity is, even though you might sometimes feel, okay, this is not exactly accessible, but I'm trying to show that they actually put in large efforts to make it work better.
I have a quick question.
Sure.
I was wondering, how is R making it easier for us? Because I use like Power BI or Tableau, and there you can kind of do this visually, like you can manipulate data and like play around, remove errors and stuff. So like, how is R better? Because here you have to intuitively visualize it for yourself, right?
Yeah. So it's so that question. So I didn't use Tableau, so like I didn't exactly understand the experience, but like the way I understand it is, yesterday I say that there are two different ways you can use R. One is using R script, right? And then the other one is using R Markdown. So if you're using R script and then if you run something, you can see the output here, not inside this source panel. But if you're using R Markdown, if you do something, it appears inside here. So it's kind of more seamless process. So that's one plus. And what that implies is, if you spot some error, if you spot something weird, you can actually think about what's the problem and then fix it. So that's why I feel like even though there are pros and cons of using R script and R Markdown, sometimes R Markdown is very useful, especially when you are developing code for the project you are doing. And actually, I'm gonna give you like one example for this. So if you take a look at this output, take a close look. So there is actually one problem for this data. Okay, we now solve the problem for the shaping problem. Okay, the original data was too wide. Now it looks fine because we fixed the problem using pivot longer. So using pivoting, this looks fine. But I suggest that if you take a closer look, there is one remaining problem. Can you catch it? What's the problem here? I give you time. So there's one tiny problem. Oh, data type. Yeah, mine sounds cute. So data type of the year variable. So what's wrong about it? Yeah, it's a character. And it should be integer, yeah, or numeric. So in R, numeric has two types. One is integer. What is the other one? I forgot. So one is like a decimal and the other is non-decimal. So integer is yeah, that one. Oh yeah, double. Double is for decimal number in R. Yeah. So this year one is wrong. So in the past, if you notice that kind of problem, then what you're gonna do is do something like this: new table, and then new table. Maybe this is year, and then you can coerce it as numeric. Yeah. Oh yeah, I did not assign yet. So if I assign this, you can see something appears in the global environment. There is a new table. That's the name of the this object, and this object is data frame because it has 6 observations and variables. So 2 dimensions, 3 columns, and 6 rows. And then we notice that this year is wrong in terms of data type, and we are not fixing it using coercing. So we are coercing this year variable into numeric. So after you do this, you check new table, you see that now year seems fine. But there is actually easier way in the tidyverse. So like one of the ideas about tidyverse is do everything as quickly and as easily possible. So what they do is instead of doing this, taking another step, you can just add another argument. So the argument is called a names transform. So if your values needs to be transformed, you can do that. You can just give the list of what is the value you are the variable you need to transform, and that's going to be here, and then set, and then what is the thing that you need to do. So read R, you can actually do using parser numbers fine, or also you can do as numeric is fine. So either is fine. But parse number is a kind of more general solution. So also let me ask a question: have you used the parse number thingy? So it's a kind of similar to as numeric, but it's more flexible and an extendable solution. You know, yeah. So read R is also part of the tidyverse. And let me demonstrate what I mean by that. So if I get let's say 1999, this is obviously a character. And then if you use as numeric, this is going to be 1999, right? But if I have this, it does not work, right? Then you gotta NA or missing value, but it's actually not missing value. So sometimes when you're using R, you got this error message called NAs introduced by coercion. And then this is a demonstration that why this error occurs. It's one of those cases. So you got this character has number. It's a mix of a number, numeric data, and then character data. And you're trying to force that transform into numeric data, and it doesn't work. Because obviously this one is number, but this is not, right? And what R is gonna do is just sending out an error message, but the error message is actually not very friendly, we just use NAs. So sometimes when you're doing something in R and then you got this like fantastic error message in red, which is very alarming because something is wrong. But I exactly didn't tell what was the problem. But then you take a look at the data, you realize that, oh, it's because it's a mix of bunch, right? So one is a number and the other one is character. So that's why I caused this error. But if I use this parse number function, so what parse number does is actually it's a little bit more complicated. So as Marissa said, it's actually regular expression behind. So but like they don't, so the tidyverse team don't want you to need to understand this regular expression thingy because it's a little bit complex. So, but name, the function name kind of so implies what it does. So every time you see objects is a thing, and function is, I say, technically speaking, function is taking some input and doing some computation, and then returning some output. Another way you can think of a function is a verb, right? A function is a verb. So function do something. So here, what this function does is it takes input, and what's going to be the output? Whatever numeric element in the input, it's gonna capture it, and then it's gonna return it as a numeric output. So that's what this pass number does. So you can, when you are doing names transform, you can use as numeric, or you can use pass number. But I prefer using pass number rather than as numeric, because sometimes the cases the mass data I have is nearly messy. It's not just this year data is stored in a character format, even though I want it to be numeric. Sometimes, because sometimes it's not it's not automatically decoded data. Some undergraduate or some people need to enter data, and then sometimes they make typos. So there is not 990, there's 998, and then you need to fix the problem. And then what you're going to do is you need to do Google search, and then thinking about, okay, what is the thing I need to do? And I say it's kind of same thing that I showed earlier about tidy data or this whole package. You first need to think about what is the output you want, and then you need to think about the kind of computation that's involved in the process. So here the output you want is, okay, if there's a mix of bunch, I only get the number. And unfortunately, there's a function called pass number from readr that exactly does that. And actually readr has lots of other related functions. So not only number, there's a pass character, pass date time, pass double, factor, get, actually there's guess. So if you have no idea, they can guess for you, giving some cues, and the integer, logical, and so on. So if your data is messy, you need to clean it up. Tidyverse has lots of great tools to make your life easy. So that's why I'm talking about this, maybe even though this seems too obvious to many of you. But hopefully this could be useful for your work. Yeah, there's also pass number and other stuff. Okay, let's talk about other data. It looks like it only takes the first set of numbers. Is there a way to, yeah, I appreciate negative sign too. Yeah, so it's not very perfect. So if you have a little bit more complex case, let me take a look at the pass number again. So usually when you nearalize that the function has a limited uses, there are two things that usually I'm gonna do. So the first thing is I'm checking the function documentation and whether there are other things I can take advantage of. So locale, prim US. Yeah, maybe this argument could be used for deciding whether reading or training white space your trim. Yeah, so you can try different arguments whether they could be useful for you, or if this doesn't work, then your option is actually using the regular expression. That's kind of more universal fundamental solution to the problem. So sometimes the solution that other people came up with may be working for your problem, but sometimes your problem is just too complex or too custom problem. Then you need to build your custom function or you just need to like your one code to fix that. But yeah, but that's a fantastic catch. I haven't thought about it, honestly. Yeah, Todd's point is also big spot on. So let me show another messy case. So we are going to talk about lots of messy cases and which one is going to work, which one is not going to work. And then after we're talking about this one type of messy case, and let's take a break. So please bear with me a little bit more. So this is a Beaver chart. I don't know what year it was. Yeah, Tupac is here. Okay, oh yeah, 2000, but still 2000, good. So if you take a look at these Billboard data, what's wrong about this data in terms of the tidy principles? So there's the R variable, there's a track, there's a data enter. Maybe this is a timestamp if it's a database. And then there's lots of WK week stuff. There are lots of weeks actually. How many weeks? Yeah. What, so from like, so given like if you take a look at this data, what your intuition tells that, you know, what's wrong with this data? Another way to put it is, are these variables are really variables? And are these rows are nearly observations? Yeah, so Marisa say the weeks. Marisa, can you elaborate on what do you mean by it?
Yes, it'd be easy for me to say it. So as I'm looking at it, of course, I'm trying to figure out how they're trying to present the data. So it's, the data are messy, but then also I don't know a lot about it. But yeah, it seems like the weeks, the numbers of the weeks should be its own variable, because I'm assuming it's going by the weeks within that year. So week 1, week 2, week 3. So potentially a variable called week with the corresponding number, because I'm not sure what the values under week 1, week 2, week 3 are representing.
Yeah. So one thing I found from consulting Berkeley undergraduate graduate students is, for those people who haven't used the data for modeling, they tended to keep their data in the wide format. And I fear maybe this is more natural for most people when they are looking at the data, okay? Because there are different weeks. I want to see observations about them like in each week in this wide format, because it's for me easier to understand the pattern. And then, okay, week 1, because to see where there's a time trend or whatever. So maybe that's why people are picking up. But if you want to visualize this data, if you want to model it, then you need to transform that into a tidy format. So tidy format is fundamental, because we talk a lot about, you know, data wrangling and then data cleaning stuff. But like when you're, the reason that you want to clean or wrangle data is because there are next steps. Maybe the next step is going to be modeling data or visualizing data. So you need to think about what is the format I need to have to model and visualize my data. And then what tidy model emphasizes is that, okay, these are sounds very simple, but these are the fundamental structure that you need to have in your data to model and visualize your data, so that you can move to the next steps. So this data, I don't say this data is not, this data presentation is not valuable, but I'm saying if you want to, you know, model it and visualize it, you move to next steps, then you need to think about how you can change that. So again, maybe cooking analogy is useful. So you can eat whole carrot just as it is, but you need to chop it in different ways depending on what is going to be the next step. Whether you wanna put it in the soup or you wanna stir fry and so on, or you're putting it in an oven and baking it. So the problem is, another way you can put the problem is, this is too long. And sorry, this is too wide. This is too wide a format. And the natural solution is, if it's wide, you need to make it longer. And in the past, we use a gather function, and exactly it has the problems that we addressed earlier. The argument names are kind of weird, so it doesn't make sense to most people. And then the sequence of arguments doesn't exactly consistent with what most people are thinking about the problem they are facing. So the new version function called the pivot longer changed it. But one thing I hear, here's one thing that I think cool. So here the problematic columns are these WK, lots of WK stuff. But the problem is there's too many. So if I wanted to do something like, I don't know, concatenate WK1, WK2, WK3, and so on, it's just like a too time consuming, and then it's error prone. So there's a high chance that you make a typo, and that creates syntax error, and then just R freezes and saying that you do some, if you like, whenever you I say I make some I give you some error message in red, I feel like it's like telling me I'm dumb, and then you did something terribly wrong, and then you are kind of forbidden to not touch your keyboard unless you figure out what's wrong about yourself. But I kind of urge you not to do that. Because what is trying to tell you is, I just so faithful. They are just trying to exactly do what you say it to do. So whenever you make a typo, just they don't understand the typo and carry it out, and then didn't work. So one way you can do that is, okay, course, and then this argument, so it's an equal sign, and then I'm gonna put all of these WK stuff together, but they're just too many WK stuff, WK 60, whatever. But here, there is a simpler solution. So whenever you feel like you are copying and pasting, I mean, we are gonna, if you have time, we have like there are lots of things I wanna say about like how you can refactoring your code or making your code more, simplifying your code. But I don't know whether we have enough time to talk about it. So if I say just one thing about refactoring stuff, like how you can make your code simpler, the key is thinking about what you are copying and pasting, or thinking about what is the pattern that's repeated over and over. So if you think about this list of values, WK1, WK2, WK3, and so on, what's same and what changes over these many values. So if you look at the number, they are not exactly the same. But if you look at the character, WK stuff, are they same? And also think about their location, because order also matters. Right? So as Marissa said, it always starts with WK, big. And if you know the pattern, you can actually take advantage of it. So in Pivot Longer, there's a nice helper function called starts with, right? So it's from deploy R. And then you can tell to R, so it's basically teaching R. So when you feel like more getting this, understanding this process at the more interior level, and that's when you feel more like you're having a conversation with R and conversation with your machine. And then this feel like, okay, I'm becoming more fluent. And now I know what it means to teach R or my laptop to do something that I want. So I'm just telling, and then how you can do that, you need to make your machine smarter. You need to make your R smarter. So you need to tell, because you're human, you know about the pattern. It's for our job. So you see the pattern, WK, and then you tell R, okay, what I'm gonna do is, it's a larger data, it's a little complex problem, and then I don't want to type everything, but I can tell you one pattern that you can take advantage of. So every column that I wanted to put together is starts with this character, WK. And I'm gonna give the name of these column names, week, and then if I see these observations, let's call them rank. So we are creating two new columns. And let's not talk about this one yet. So if I do this, now it looks like this. So it has 4 columns and then 24,092 observations. So it kind of looks green. So we got an artist, we got a track, and then we got a date enter, timestamp, and then we got a week, right? And then if you want to drop WK, you can easily do that, because now you know this linear class number stuff. So you can take advantage of it. So yeah, but there's still one problem if you look at this rank variable. Does any of you have questions? Okay, so going back to this example. So if you, what is DBL and Agile? Yeah, so let me explain that a little bit. So here, this called DBL. So where's Agile? I think Agile is where. Yeah, Agile is basically logical, and then DBL is called a double. It's just a decimal number. So if you have a decimal number, it means that there's like you need to have more positions for the number. So double basically means you got more memory. It has more memory to save that information. So R has a numeric data type, and then in the numeric data type, there's two subcategories. So one is integer, that's for the integer, and the other one is double, that's for the decimal number. There's noise coming from. Yeah, so anyway, okay, going back to this favorite example. So if you look at these, let's take a look at rank here. So there's one problem, and maybe obvious problem. There are lots of NAs. And I usually do not recommend just dropping NAs because that's a terrible choice, right? For lots of reasons, because NAs, these missing values didn't occur. These are, these missing values didn't occur by random variation. So maybe there's some reason why your matching values stay here. But let's say you want to drop them. So in the past, if you want to do it, then you need to add another, do another function, another operation, like drop NA. But now you can just add this argument called the values drop NA, and then if you say true, then it's just gonna disappear. I do not say this is a good choice most of the time because, like I said, these random values, these missing values appear not randomly. To think about the systematic regions. They appear in the data. But if that's a simple solution you want to come up with, this is something you can do. Just values drop NA, then it's gone. Yay. And we have one more case, and then after this, we are going to take a break. Because it's kind of connected, so I want to do this together. So table 2. This data is also not tidy. But can you tell what's the problem? So does the drop the observation if any variable value is missing? Yeah, if you didn't specify that, that's the case. But in this particular case, it's kind of obvious because only rank variable has missing values. So if you look at this output from the table 2, can any of you tell what is the wrong with this data in terms of the tidy principles that we have learned so far? Yeah, so looks like a type should be split into 2 columns. So another way you can think about it is you can ask questions. Whether these variables, columns are variables, and these rows are values, then you notice that, okay, this doesn't fit into that framework. And the solution is also kind of straightforward. If you notice that the data is too long, then what should be the solution is you should make it longer. So that's why people longer comes along. And in the past, we used spread function, and spread function using the argument name, the key and value. And again, this is a very good choice for naming. If you intend the audience is people coming from database background, but for most people, other people, it doesn't make sense. So they change it. So one is the names from. So key is changed to names from, and the other changed to values from. So exactly the same thing as spread function, but just argument name and function name changer. So you now split this type variable into 2 other variables, cases and population, and then so these new variables need to take values, and they take values from this count variable in the original data frame. So let's look at the table 2 again. So this is what table 2 looks like, and then we want to split it. So if we're splitting, meaning like we need to create new columns. And so we need to think about where the column names come from. So column names coming from this type. variable in the original data frame. And the values for these columns coming from this count variable. And that's what it looks like. It's kind of neat. Yeah, and let's take a 10-minute break. And then we are talking about a little bit complex problem called implicit missing value and explicit missing value. So let's take 10-minute break. And yeah, and if you need a coffee or tea, it's your chance to get your second shot.
Can I ask you a quick question?
Yeah, sure.
Just in terms of like, I was trying to download the R Markdown yesterday, and it looks like I needed to download the LaTeX. Yeah, I don't know. Like, I guess I need to download additional things to knit this into a PDF.
Right. So if you wanna, if you're using Markdown just as it is, like just dynamic programming, so you do something combining code and text, and then see the output inside your Markdown file. This is called dynamic programming. Then you don't need to worry about like a LaTeX whatever. But maybe you also want to do extra thing that's called knitting. So you can click this, and then there are options that you can turn this Markdown into a different file format, right? So what's actually happening here is sort of like a file conversion. So you're transforming, like changing the file format from one type into the other type, right? And then for so HTML is fine, but if you want to turn that into PDF file, I think the I think neat R, that's the package name. They are using an engine called a Panda. That's for LaTeX. So they are turning the text in the Markdown file for the PDF using Panda. So you need to install Panda to make that happen. Okay. I didn't talk about it because there's additional installation involved. But I think if you go to, maybe I didn't explain that. Not install this. Let me take a look.
I guess I was just wondering, like, if I wanted to save the file that we're working on, what would be the easiest way?
Yeah, you can also need to PDF with the text. So actually, so let me share something on the Slack after this session. So actually, I have the guideline for this that I prepared for when I was teaching this course. I mean, extended version. Yeah. Okay. So there's like a whole list of things you can do if you want to use our Markdown and then also like producing PDF file.
Yes, that would be great. Thank you.
Yeah, stuff like that. Yeah, I mean, our Markdown is pretty useful. So actually, you can write a paper using our Markdown. You can prepare slides for the conference using our Markdown. You can write a book using our Markdown. You can build your website. So I built my personal website using our Markdown, and I wrote my textbook using our Markdown. So there are many use cases for our Markdown. Okay, let's get started again. Hopefully everybody's back, and then got a chance to get another drink. So let me share my screen again. iStudio. So if you can see the screen, then please type 1 so they can see that you have the access. Okay, thank you. So we covered what is tidyverse and talked about some packages like leadr, tidyr. So we covered some kind of basics, and I want to give you like a little bit more a complex case. So in R, so there are two ways I define missing values. One is called implicit missing value, and the other one is called explicit missing value. And everyone knows about, I think, this second category because, if you see express missing value, it's a flag with NA. But this implicit missing value thing is actually not very obvious. So it's one of the sources of confusion when you're transforming some data, and suddenly you find that their NA is in the data, and then you might wonder what happened. So let's take a look at this data. So I'm creating a data frame. So you can create a data frame using data frame or table, but I use table because table output is a little bit beautiful than data frame, but there's not much difference between using data frame or table to create a data frame. So table is also data frame. So I'm using 3 variables or 3 vectors. So the first one is year, the second one is quarter, and the last one is return. And then I named this data frame stocks. So if you look at the global environment, you can see that on the data, under the data label, there's another data frame created stocks, and you can know that this is data frame because it has 2 dimensions, 3 variables, and 6 observations. And if you take a look at it, this is what it looks like. So year, quarter, return. Again, this DVR is just numeric, it's a subcategory of numeric variable. Numeric data type. Okay, and then so I mean, this is not a good choice, but like I'm saying, I want to make this data frame wider, just for whatever reason. Actually, it's for the demonstration. So I'm going to make this data frame wider. So names from year. So year. So it's going to be look like a quarter, return, and then 2019, 2020. That's what I'm going to do. So I'm going to taking the names from year and then values from return. And this is what the wider format that it looks like. So these actually, I'm sorry. So these values indicate returns, and then this is quarter, and then this is 2019 and 2020. And if you compare these 2 data frames, besides the difference in the shape, whether this is longer and then like taking the longer from wider form, there's another difference you might have noticed is here you have only 1 missing value, but here you have 3 missing values. Do you know why this happens? Any intuition about this? Why do we suddenly have 3 missing values when we had just 1? Yeah, so you want to say each year doesn't have 4 quarters. That's exactly right. So if you look at these, there's a year, and then there's kind of match. It's parallel, 2019 3 and 2023 observations. Then if you look at the quarter, that's exactly not the same. It's a 1, 2, 3 quarter, and then it's a 2, 3, 4, right? So if you present it in just the longer form, it doesn't cause a problem. But if you reshape it, then certainly you got more missing values, because this missing value is actually implicit missing value, simply not present data. So when you're trying to show the match, it's not present in the original data. So you are now having the missing value. And if you understand these, there's actually a little bit more complex problem that I wanna show you. So this is a fish encounters data. I don't exactly know the context about this data, but nice thing is it has 3 variables, and then one of the 13 row observations. So fish, I guess this is different types of fishes, and then station, so locations where some people encounter these fishes, and then whether they seen or not seen. And then let's see, what is the unique value of their seen variable? It's only 1. So we have like only seen, if you look at the seen variables, it's only 1 is recorded there. Okay, and then what you want to do is turn this station into a series of dummy variables, right? So if someone observe this particular fish, and then seeing it, then it's going to be 1. If they didn't see it, it's going to be 0. So yeah, what my goal is creating a dummy variables, series of dummy variables based on this station variable. How can you do that? Using a keyboard wider. Do you have any ideas about this? So the first thing you need to do, add a column not seen. Why are there no unseen column? Yeah, so if so the question is, could you make a station of series dummy variables? So the dummy variable, this dummy variable should take the variable names from this, and then values from this. So names from this station variable, and the values should come from this scene variable. So there is no unseen, because if your scene is 0, that means unseen. So that's the idea. People wider the station and then replace NAs with 0. So Todd Hall. Okay, so that's all great ideas. So let's then think about how to actually do that. So here we go. So we got our spacing counters. Then we are using keyboard wider. So names from, so this is like very simple because it's straightforward. Names from station, and then values from scene. So we create a bunch of dummy variables here. But the problem is, as Todd rightly pointed out, there is a bunch of NAs. And then why do we have NAs? We understand why suddenly we have NAs, because you understand the implicit missing value. So these are the implicit missing values. So when you are seeing the data in this way, there's a 0 NA. But when you are transform data, reshaping data, then we suddenly see these NAs because they are implicit NAs. So they are not seen it before because we didn't think about the match. But now we turn that into dummy variable, so that's why you're seeing it. And then we want to change this NA with 0, because that's what dummy variable is about. And it's pretty easy because there's another argument for values field. And then you start to do this. Then now we have a series of dummy variables. And I love this example because when I was using this as a problem set and then asking students solving this problem, even though we covered implicit missing values and the shaping problem, they usually do something like this: fish encounters, and then maybe degrees. It's like fish encounters and something like that. You're trying to create a variable, each variable one by one using if else and so on and so forth. But what I'm trying to encourage you to do here is first thinking about what kind of big structure that you wanna have in the end, right? So always thinking about the end goal. So the end goal is I'm gonna create a series of dummy variables. Another way you can think about this, maybe this is too long, I'm gonna make it wider. And if you're gonna create a series of new variables, you need to think about, okay, these variables have names and then values. And you need to think about where those names come from and where those values come from. And if you identify those two elements, these two, right? You see the one last thing that you need to solve is this NA thing. So you can use is NA, then identify NA and then replace it, or you can take advantage of the function, because if the function has an argument called values field, and you can just add another argument, and this is done. So what I'm trying to encourage you here is like when you are learning tidyverse, it's actually like there's a kind of deep principle embedded in these functions and packages. So there's like lots of thinking, deep thinking involved behind these functions packages. And if you understand them, if you grasp them, actually there are many use cases you can use that. So this is not exactly like a data wrangling problem, right? I mean, it's not traditional data, a conventional, typical data wrangling problem, because it's creating a new variable, dummy variables. But actually, you can use the principles that you learn from pivot wider, pivot longer, and then use it, and then make it very simple. So various appear only if it's NAs. You can make a scene equals, so yeah, only if you're NAs. That's exactly correct. Yeah, and actually, I'm going to talk a little bit about field later. So this is nice because it has only like 5 lines, but you got a nearly large number of new variables very quickly. So I think this is a beautiful solution. So sometimes like when I got an error and I didn't understand it, that's very frustrating, because usually I need to go back to the source and then understand what's going to happen there. But whenever I came up with this kind of nice solution, it's fine. Okay, so yeah, that's about pivot widen and longer, reshaping problem. And there's another kind of minor problem about that's covered by tidyr package, which is separate and then unite. So separate is this kind of problem. So let me show this. So there is a variable called x, and then if you look at this variable, there's a dad.apple, mom.orange, and then Doro.banana. I'm not saying I prefer apple, my wife prefer orange, and then my daughter prefers banana, but just an example. And then there's a problem for these values. This is not exactly shaping problem, but there was somewhat related. What's the problem here about this particular data frame? If you think about it, but still, again, it's the same thing. It's a tidy principle. Whether this variable, this should be like one variable or separate variable, 2 observations combined to 1. Yeah. So even though there's so many different tools, that's what's nice about this tidyverse framework. Even though there are so many different tools and so on, but it's all boiled down to like a one principle, which is tidy data principle. So whether this data follows the tidy data framework or not. So it's not, because it's combined. We need to separate it. And there's actually function called separated. And then function name, if you understand what function is, the names start making sense. Because function is doing something, and then what you need to do here is separate these things. So that's why there's a separate function. And separate function taking this column and then dividing the column into these 2 new columns, called name and prefer fruit. So if you do this, yay, you got this one. So there is a separate function, and it's like there's a pivot wider. It's like yin and yang. So there's a pivot wider and pivot longer. And the reason is sometimes data is too long, data frame is too long. Sometimes data frame is too wide. So you need to have 2 functions to deal with the problem. It's the same thing. So sometimes you need to separate the values in a column. Sometimes you need to unite into 2 columns into 1. So because there is a separate function, there is also a function called unite. So there's a separate and there's a unite. I didn't cover separate unite in depth because they are too obvious to me, but it's good to know about those things. And there's one more thing about tidyr. Usually it's not very well covered in the R intro class because maybe it's a little bit advanced, but I found it super useful. This is called on the field functions. So let me first show what the data looks like. So this is again data frame. So it has 3 columns called the quarter, year, and stock price. Okay, so let me take a look at what the data looks like. Oh, so the period was the separator. So this kind of differs. So if you look at, so I'm responding to Todd's question. So if you look at, I think it's tidier. Tidier separate. If you look at the documentation, you can see that this is the default separator. Yeah. So whenever you are wondering about like what is the default setting, use the quotation mark and then look at the documentation. Okay, going back to stock example. So this is what the data looks like. 8 rows and 3 columns, and there's 2000, 2001. And then if you look at this, there are lots of missing values, but it's actually maybe not missing values. For example, I asked my undergrad to enter data for my project, and then my undergrad like manually typing each value and then got tired. So just like type 1 value for year, and then for the rest of it, just left it blank. So that's what happened here. Let's say that's the situation we have. And to me, it actually happened a lot. So whenever asking somebody to do the data entry work for me, because it's not a very stimulating work, they try to minimize the effort, try to make sense. And this is the output I have. And in the past, also I just confessed what I did. In the past, what I did is I opened an Excel, and then maybe I drag this, and then so I could fill these missing values with 2000. And I did drag this, I fill this missing any values with 2001. And I hope that I'm not the only one who have done this kind of thing. So if you have done filling missing values using a spreadsheet and so on, please type 1 so that I know that I have some company. Thank you so much, guys. So I'm not the only one who did that. But the problem is like there are 2 problems about that practice. One is of scale. So how about like you got like 1 million observations? Well, how can I do that? And the other one is reproducibility. So if you like open your spreadsheet and then this is what you did, and if someone else is trying to replicate your practice, they have no idea. You're saying I opened my Excel, I fixed what my undergrad gave to me, and this is what I got. But that's not very satisfying or transparent explanation. But here is like another solution is using a function called fill. So idea fill. You can, idea fill. Wait. Yeah, the data is missing. Yeah, so there's a direction that's done about, so there's a direct, so data, and then taking the variable, you can take 1 variable or many variables, and you can take a direction, whether you go down, up, down, up, down, and so on. So I think the property is down. So if I do this, here stock, and the missing value is found in a year, and then the direction I'm taking is down. I think that's the default. And what you observe is the missing values are not all fill. So what it does is we are taking this data frame, and then we are looking at these missing values in this year, and whatever we found the value, and then the rest of the missing values is going to fill by this value. And then it does that until we found another value. And then if we see another other missing values, they are going to fill by the other value present in the data frame. And to me, this is a cool and useful in many cases, but especially useful when you have time series data. Right? So you got time series data, and then it has some like discrete observations. Like you got an observation about 1990, 1991, 1993, something. But the problem is you are missing data from 1992. And then what you want to is you want to fill this 1992 data, and then you want to having observations like for 0 for that. but actually you are missing that. So you don't, if you didn't observe from a particular year, that means you didn't have any observation, something like that. So if you want to do that kind of, data wrangling using this field is wonderful. So I recommend you to spend spending some time to look at the documentation for the field function and understand how you can use it for your work. So this is pretty useful, especially if you have time series data. Yeah, and I gave you like a little bit more complex example. Yeah, such deeper directions down. So this is YEP rate. So let's look at this YEP data, hypothetical YEP data. So there's different neighborhoods. I just named that N1, N2, N2, 3, and N4, and there are different restaurant type and popularity rate. And you can decide whether a default direction is going down. So if I do that, it's the last two admission values are filtered by the first value observed here, and then same for the second one. But let's say if we decide to go up, what's going to happen? So is it going to be Chinese or is it going to be Indian? So the second law for the restaurant type. If I change the direction from down to up, what's going to happen? Indian, yeah, that's true. Let's see whether we are right. Yep, it changes. So it's a pretty simple, but you can fill these missing values in a kind of principled and systematic way. So thinking about the pattern. So yeah, so like it's teaching computer is like it's all about thinking about pattern. And if you know about the pattern, then you can take advantage of it, and it can make your life so easy because your computer is very, very powerful. Your personal computer is very powerful, but in order for it to use its full power, they need to have some knowledge about data structure they can take advantage of. So if you can tell them the functions, the patterns, and then if you can use it, you can either use your own functions where you can take advantage of the functions developed by other people. That's gonna make your life so easy. So we talk about tidy odd function. That's the kind of the cornerstone in the tidyverse framework. And there's another actually more popular package called the dplyr. So if the tidyr package is more about like reshaping data kind of stuff, and dplyr is more about manipulating. And when I'm saying about manipulating, it's like saying like there's data frame is basically having two dimensions, columns and rows. And here the problem is like whether column is too long or row is too long, the length of row or the length of column too long. That's not the problem. We have specific issues about columns and rows, and maybe you want to present information in slightly different ways, or we want to filter data frame. You want to get a subset of it, not the entire data. So that's what this dplyr thing does. So like one of the basic things is like rearrange. So there's empty cars is one of the built-in data frame from R. Yeah, so different car and their features, and you can arrange it this data frame using MPG variable. The default is low to high. So if you look at MPG, this is low to high. This is what orange is about. I mean, we don't change the structure of the data frame. It's the row in a number of row, variables, number of columns, number of observations exactly same. We just change the presentation of data. That's what arrange function does. But maybe you want to make it descending order, then just adding DSC, that's descending, and change it. And this orange is good because sometimes, because sometimes you want to see what is the car that has the highest capacity based on MPG or something like that. And rename is sometimes you notice that. So let's say this is the data you got, BF, and this is not terribly good. Again, we are not changing anything about the structure of the data frame. You don't change the number, the structure, the shape. What you're going to change is just the name, because this name is not intuitive. So we're going to change it from old name year to new name, old name Y to a new name year. So that's what we are going to do. So that's what I mean by manipulation. We don't touch the shape. We only touch about the content. And the other thing is subset. And this is actually very fun topic. So subset is a huge topic. And then you can subset something based on either columns or rows. Maybe this is obvious. If you think of a data frame is two-dimensional data, right? So which means you have columns and rows. And if you think of subsetting it, you can subset it based on either columns or you can subset it based on rows. And then, so let's talk about one problem at a time. So if you're saying, so you gotta reshape the data. So in terms of shape, it's fine. It's not too long, not too wide. And then what we want to do is, as a next step, I want to do, so usually what you do is first we thinking about shaping problem. Okay, whether there's something I should do using tidyr. And after you've got this step, and then we're moving to the deployer problem. That's more about manipulation. Okay, now the frame is right. Now the shape is right. And I'm going to think about the content, the variable name, like, all those things are good. Or sometimes I want to reduce the data size because it's too much, or it contains too much information that's unnecessary for the work I need to do. So I just need to subset it in a way that's more useful for me. So I got a Star Wars data because I like Star Wars. And I know that's a good reason, but personally motivated. So, and then here what I want to do is I want to subset this data frame based on this particular variable called gender and this particular value called feminine. So basically I'm subsetting only feminine gender. That's what filter is about. So if you think of filter, okay, data frame is 2 dimensions and you're talking about, rows, because we're subsetting rows. And then for the outcome, I arrange it using descending order for their height. So if I do this, this is going to be output. So if you think about the difference between Star Wars and this new one, dim is a dimension. If I do this, dimension is 87 observations and then 14 columns. And if I do this, what's going to change? We are going to have a new number for column or new number for a row. Any idea? Row or column? Yeah, you see that row is substantially reduced. The reason is because we use a filter. So a filter is for subsetting based on, subsetting rows, but if you can subset columns as well, that's a select. So select is for subsetting columns and then filter is for subsetting rows. So if you use a filter, you should see that the number of rows should be reduced. If you use select, you should see that the number of columns should be reduced. So there are so many things in the happening deployer. It has just so many functions, but actually it's like very well designed, meaning there's like a very systematic way everything is designed and then working together. It's not like just these people creating random stuff and then putting them together and then branding them as a tidyverse framework. It's actually a framework. And yeah, so another filter example is like this one. So this one is based on logical condition, like whether gender equal feminine is true or false. So what it's actually happening behind the scene is if gender equals feminine is true, that's how the rows are filtered. But if the variable is not a character vector but numeric, then you can think about kind of with a relationship between this value, the value from this variable and then particular number, and that's what I'm doing here. So I'm filtering Star Wars data frame based on this variable called height. So smaller than around 80, and then it's a centimeter, I think, not inch. And then higher than higher than 160. So n row is the number of rows. And I'm trying to show that these two are exactly doing the same. So if you want to make this function satisfy these two conditions simultaneously, you can use either comma or, yeah, this sign and sign. They are doing exactly the same thing. But this one is not doing exactly the same. Great. This logical operator means and, but this means, anybody know? Yeah, this is something that you learn from your I course, camp. Yeah, or. So they should not do the same. And if you think about number of rows, is it this, this output is 24, right? And I say this is exactly the same. But how about this? Is it going to be, this one is going to be same as these or larger? If you think about the output is going to be larger, I mean, greater or smaller? Because we are using or. Yep. Great. And that's why you're going to see it. Yeah. So it depends on how you set things up. So there's another one called between. I'm not talking about this in this session because it's maybe too much detail one, but if you're interested, you can take a look at it as well. Well, maybe this is useful. So here, I'm looking at the name and then thinking about it, there's a name, and then only filtering names, character names, which have R's in them. Why something I cannot type? Yeah, let me see. Yes, only my mouse doesn't work. My mouse works, but my keyboard doesn't work. Oh, just give me a sec. It's weird. But yeah, my mouse works, but my keyboard doesn't work inside iStudio. Something happens, and I need to do this again. I'm very sorry. Yeah, but taking on advantage of the iStudio project. So I'm gonna just refresh everything. This works, and then I'm going to go subset here, a single line on this. Yay. So Star Wars example, and then this one. Good. Okay. So yeah, now my keyboard works. Okay, so what I want to do is subset rows, right? Because I'm using creator function. But here, what I want to do is looking at the variable name. Yeah, it's not very intuitive. Variable name, and then looking at the list of these names there, and then finding rows, finding characters, observations whose name contains R's. So that's the pattern that I'm using. And if I'm using base R, this is the function I should use called grapple. But if I'm using tidyr, because tidyverse has string manipulation package called stringr, and then str detect is one of these. The functions coming from stringr. So I just use the function. So what it does is lowercase name, and then if that name has R's in it, and I'm gonna filter that. So if you look at this output, yay, so you can see that those names all have this same pattern, R's, last, harsh, yeah, so you see that. But how about like if I want to use multiple patterns, not just the one pattern, but many. So in that case, one operator that could be super useful is in operator. Have you used in your work? Do you know in operator? Yeah, mine says say yes. Yeah, again, this is also from SQL. Yeah, so in is pretty cool. So because you can, it's a kind of set concept. So hair color, so if you look at hair color, oops, sorry. Hair. Yeah, if you look at the hair color variable, and then what are those unique values in there? These are the unique values. So like for black and brown, there are like some combinations like brown, gray, and so on. And I wanted to pick up every observations that includes either black or brown. Then you can use this in operator. If you do that, and then if you look at their hair color, this is what it looks like. Yeah, actually, this is not exactly good because there's some complicated cases like a black and brown, so you need to think a little bit further. But just the point is, if you have one option, you can do something like this. Or if you have multiple options, and if you're thinking about set, like in a set concept, then you can use in. Yeah, so that's it. And there's one change for using str detect. And one thing I also want to highlight here is there's kind of pattern for the package name. So remember this, read R. So read, and then there's R. And then deploy R, then tidy R, and then string R. So there's a kind of pattern in the way they name packages. In case that's useful for you to remember those package names. So there are just way too many packages. And there is another function that could use for is called a slice function. So let's say I arrange of these characters based on their height in the descending order, and I want to see who are the top 6 characters. If that's the case, you can use slice function. It's showing the first 6 observations from the top. So and then sometimes you want to show like only 10% of their observations from the top. So let's say you got a whole data, you want to see like only the top 10% of the data. And you can, in the past, you use this function called sample, random sample. So sorry, not the top 10%. So you are just choosing, randomly choosing 10% of the observations from the data frame. In the past, if that's what you want, first thing you need to do is this thing, because you want to make your code reproducible. So if someone also doing this random sampling, they're going to use exactly the same seed, because that's why you want to set seed here. Yeah, so you can use, for the set, you can use 1, 2, 3, 4, 1, 2, 3, it doesn't matter. I mean, there's like one, I've seen like there's that argument that you need to set like a certain large number for that. I mean, larger number rather than certain number, because there's an issue about if you have too small seed, then so on, but like can exactly recall what was the argument. But the point is actually, I think the number doesn't much matter. You can put whatever number you want to, though there's one question about it, though I can't remember what's the argument about. But the principle here is, if you're doing random sampling, by design, each person do random sampling, and then whenever they're doing it, they got like not exactly same sequence of observations. And to prevent that this causing issue for reproducibility, you need to do something like set.c, so that everyone, when they're doing the random sampling here, they're going to have exactly same output. So that is the idea. So I've seen people like bring like their birthday and their zip code, and I recommend you not to do that. I don't think that's a good practice for privacy and other reasons. And I think Nania, the organizer, has lots more to say about that. But in my practice, don't do it. So I usually just put like 1, 2, 3, 4, 5, 6, whatever, or today's date, something like that. Just don't put your social security number, birth date, or zip code. I think that's not good. So if you can just sample 10%, in the past, you just sample frag. So one thing, the other thing that Tidyverse team Neorize is, okay, they are expanding the number of packages in Verb, number of functions in Verb, because they want to cover almost every aspect of their science workflow from the beginning to end. So they're going to create end-to-end, toolbox that covers everything. But this ambition has also downside. What is downside? It's like people are going to have a hard time remember all of these functions, all these packages, and when they should and how they should and things like that. And this is something that I'm trying to cover here. So what they changed recently is like unifying the names. Unifying the names. I think that's a pretty good sign. So in the past, they have a sample underscore frag function, but I doubt how many people you actually use this function. If you use the sample underscore frag function in your work, please type 1 in the chat, because I've never seen any person using it besides myself. Oh, myself, pretty good. Yeah, I found another company who used it, but it's kind of rare. So not many people are using it. And the reason is, I think it's kind of obscure. So unless like accidentally you find this function, it's kind of difficult to know that this function exists, and then you can actually use it. So what they're trying to do that is they first come up with this slice function. So slice function is like exactly same as, you know, like head. So you can do the same thing as, you know, head is 6. Head is 6, and then you're gonna get exactly, I think, same output. So head function is a baseline function, and then like it's showing like if you have data frame, and then it shows the certain number of rows observations for the data frame, right? That's head. And then like you might complain, okay, you got a slice, just a different branding of the same function as a head. But if I understand their design choice, actually they have like, I mean, there's an ambition involved. It's not just about, you know, replacing head, that's the goal. Hey, we have a larger dream, a larger ambition, and I'm going to show what is it. So we talk about wrapper. So like there's a function is basically verb, right? And there's a wrapper. Wrapper is so if there are like a number of different functions and packages, and then if you want to have like a better interface, easier interface, that function is called the wrapper. So wrapper is also very useful. So because, you know, there are so many functions, so many packages, and then I want to have a unified framework. That's wrapper. So if you think about scikit-learn in Python, or tidy models in R, those like a big machine learning package there. What they do is they're kind of providing unifying framework for machine learning. So everybody can use different algorithms just using one framework. So it's kind of the same idea. That's wrapper. And there's another function type called helper. So anybody know like the helper function? So function is basically verb. Okay, 0 is good. So helper function can add a verb, right? So it's like a changes the behavior function. That's the helper. So here we got a slice function, which is pretty wonderful, but it's exactly doing the same thing as it had. It's not very exciting, you know. Yeah, what is that? What's the big deal? So they come with, okay, sample frag exists, but nobody uses it. And then they're showing that the connection between sample frag and then this slice function. Okay, actually slice function is, I mean, this sample frag is an extension of slice function. So we should call it slice sample. We are slicing it, but also doing the sampling. So that's why this is a slice sample. And a slice sample, and then you can decide whether randomly sampling 10% prop based on replacing either replacement or without replacement and so on. So that's the extension. So you can slice using sampling, not just to top whatever number in the data frame, or you can slice sample not size sample based on that proportion, but the number. Then you can do this size sample, then just change the prop argument with n and training. That's why we do it. It's pretty useful. So one concept is, so the reason that I'm talking about this is not like particularly talking about slice function, but I want to talk about the concept called helper and how like one function is extended and related to other functions. So there is a slice function, which might be not very exciting. But then it can be extended to other series of functions like a slice sample. And then you can use it for sampling, random sampling. But then you can use it for the random assignment or random sampling for the, like, when you have survey data and stuff like that. And it's pretty cool, right? And then also there's a top n function. Also, again, question, have you used the top _n function in the past? Who used it? Satali used it. Zero. Okay. So it's another function, pretty useful, but none people used it for whatever reason. And so what they changed is showing the connection between this function and slice. Okay, this is actually slice max. So if you want to find the top 10 tourist people, individuals, you can just choose the variable and then n set 10. Then you got it. Yeah. So slice series, and then you might question about, hey Jay, it's so useful, but I want to find like every single slice function. How you can is there an easy way? Yeah, easy way. It's just a 2 column, and then you can get the namespace, and then see slice, and you can see all these beautiful slice functions: head, mean, sample, tail, whatever. Yeah, and then look at the documentation, and then see what could be useful, what function is useful for the particular work that you need to do. Okay. So here again, the goal is like not trying to show like teaching you this particular slice function, but introduce the concept about helper and how you can get this series function looking at the namespace. Yeah, this is how I use. So I'm also a software developer, so I develop functions and packages. This is how I develop functions and packages. Also, this is how I understand how other people develop functions and packages. Okay, so slice is beautiful. So guys, we don't need now rows. Now we are moving to the columns. Okay, so data frame is a 2-dimension rows and columns. We first talk about rows, and now we are moving to columns. And also this is a kind of systematic reason. So if you are like dealing with text data, image data, and stuff like that, these data are high dimensional data, meaning like there are lots of variables, even more than number of rows. But like if you got a spreadsheet kind of data, usually there are lots of rows, and the number of rows is usually greater than number of columns. That's why you're first talking about self-same rows, but self-same columns are also very exciting, and then dplyr has lots of tools. So the data we are using is called M-sleep data. The name, genus, or order, conservation, sleep tour, sleep data. I think this is near cool data. Different animals, cheetah, owl monkey, mountain beaver, and so on. This is pretty cool. And if I have time, I want to spend more time on this. Like I didn't exactly know about the context of this data. I feel like this is very cool, cool data. I mean, like I studied political science, but if I got a second chance, I wanted to study biology, but I didn't. But like one PhD was hard enough for me, so I decided not to do that. But anyway, M-sleep data, and this is the number of variables here. So we got 11 variables: name, genus, and so on, body weight, and brain weight, and so on. And if you look at the this M-sleep data frame, there are lots of information. Like there's an rows. Also, you can see there are different types of data. So some are character, some are double, and so on and so forth. And how about if I only want to see numeric data? If you so if your goal is like getting subsetting only columns that have particular, and those, belong to the same category of data type, there is one way, an easy way you can do that is using this. Where is numeric? Then the output is only numeric data. Yeah, you can, obviously you can do that in this way. And first you see M-sleep, and then you check which one is numeric. And then you can select and then just to call each one. Okay, sleep tour and sleep RAM and stuff like that. You can type each variable one by one, or you can think about the pattern and then using the function that take advantage of the pattern. And to me, this is better. It's more systematic, and there's a less chance for you to make a mistake. But the assumption is the data type is correct, right? So that's why I emphasized earlier that you should check the data type If there's something wrong about data type, for example, year is character, they need to fix that. People thinking about this. So usually the recommended framework is before thinking about deployer, first thinking about tidyr. So first thinking about shaping and dimension or data type kind of stuff. If that's correct, then thinking about deployer kind of work, more about manipulation. Sorry, something dropped. And how about this? So if I want to select the columns that include the street in their names. So this is another pattern. This is another pattern, right? The pattern is not the data type. It's about the names of these columns. So I'm going to for that one, I just provide my code, but there's another one you can actually do something about this. So for that, still you're using select, but instead of where is for the data type, you're using another function called the wrapper function called contains. So whether the name contains street. And if I do that, you only get columns which have street in their names. I think this is a much elegant solution for selecting columns. So how then can you select the columns that include either street or WT in their names? Does any of you have an idea about this? Okay, do that. Yeah, Boolean. So you got an intuition. So mstrip, deployer, select. But if so let's say I do this, street or WT, it doesn't work. And the reason is, I think you should use this to match it. So if that's the thing you want, you should not use contains, but use matches. So there's a different lever. So it's not contains, but matches. Yeah, so just one condition, then use sleep. If there are two conditions, more than two conditions involved, then use matches. And there's another, so this is something we actually practiced earlier. If you want to select the columns, starts with a particular string pattern, you can just start with. So this is gonna start with, so selecting columns starting with B. And then this one is gonna selecting columns ends with WT. Yay. This is pretty cool. And then soon we are going to have another break and then see you again. And then we are going to talk about modeling and visualization a little bit. So bear with me just 1 second because we're almost done. I'm going to skip this order everything kind of stuff. You can check it by yourself because it's kind of easy. Yeah, and this one is fine. So I think, yeah, you can also check it for yourself. The other package, maybe that's what's useful, is called the janitor. So anybody using janitor, it's not from tidyverse, but it's also very useful. Janitor package, anyone using it? Yeah, 0 use for janitor. Yeah, janitor is pretty popular. And let me show like a one use case for that. So there's a matchy DF data frame. So this data frame, and the problem for that is this like a column names. So this is not exactly a tidy problem. So we gotta, but like, I mean, slightly related to that, but it's kind of really complex. And let's see what this clean names does. So basically kind of providing unified naming convention for the column name. So the original column name is looks like this. So the problem is this is capitalized here, it's whole capitalized, and then this is kind of separated, and then make sure we don't need this one, and then norm 3. So like there's no consistent pattern for the naming each column. So that's the problem. And then what curly names does is, I mean, still we have this underscore, you need to remove that, but otherwise we all have the same pattern. So curly names is another good function that you want to know for cleaning column names. So inconsistent data entry is like one of the main sources of the, main issues for the data cleaning and wrangling. So there are other functions that are used for deployer, mutate for creating variables. And then this is a poll function. So you also use a poll. So there's a mutate, and then there's case ran is also, you can combine mutate and case ran to transform our continuous variable into categorical variable if that's what you want. And the pool is also pretty cool. If you haven't checked it out, I highly recommend to check it out. But otherwise, let's start here because we have only like 20 minutes something. But I think I talked too much and I need a break. So again, 10-minute break. And then I talk near quickly about, or briefly about modeling and visualization. So 10-minute break. But I'm gonna linger here in case if you need to talk to me about deployer or tidyverse in general.
Dr. Kim, this is a, I guess, broader question, but with a lot of the new functions and new packages, and they're doing similar things or like replacing old things, how are things deprecated in R? Like if I use the old function, would I get an error message and would it tell me the new one, or is it just like, is there anyone managing that?
Yeah, actually, yeah, life cycle. So tidyverse now has a life cycle for that stages. So this is life cycle package, and then now tidyverse is using it. So if you look at the documentation from the package website, something they usually indicate whether the function is experimental, so it's becoming report stable, that it's stable, and then somebody realized that okay, this is the problem is this function, they become deprecated, and then maybe there's a new function and then they should proceed and so on. So now they are tagging the stage of their particular function or package according to this life cycle. So many people are aware of the problem that exactly you mentioned, and then trying to deal with it more systematically.
Okay, that's super helpful. I will really check out that website. Thanks.
Yeah, tidyverse team doing it, but I don't know how widespread this practice is, but I think this is actually, like you said, it's a good practice because we just need to be aware what's the stage for the functions or package they are using. Yeah. Because we want to, like, when you're writing some code, you want to make that, we want hope that they can work years later and somebody picking it up. Yeah. So there's another related issues, like maybe how you can build a container for that. So like whether, so it's kind of building a time capsule. So you create an image for your environment. So years later, when somebody picking it, they don't need to like install new packages. They are using the package used at the moment, and then use the function they use at the moment, and then so that they can deprecate the things that you did. So there's another thing that you need to take into consideration. But from the developer side, they need to think of a life cycle and the tagging and sharing the information. And from the user side, to think about like how you can create a container or Docker image kind of for that, so that when other people are picking it up years later, they can still reproduce it. I think most of the code used in soil science, because you don't think about these problems systematically or seriously enough. To be frank, I don't think our code is not very reproducible in general. So if a graduate student 5 years later, if they pick up some codes from their Dataverse repository and then pick up some code and trying to reproduce it, they're going to have a very hard time to do that.
Dr. Kim, I had a quick question in regards to like making sure that R is as updated as possible. I know with like Stata, other kind of packages, like before you even start the program, it'll like ask you if you want to put any updates. How do you make sure that you're as up to date with R, like as possible, like every time you kind of upload it or start the program on your computer?
Yeah, so there are two things. One is, so let me go back to my iStudio. So if you look at the tools, you can see this one, check for package updates. So if you got a package install, this feature automatically checks what is your install version and then what is your available version. And if you want to update, you can update. So I do this like from time to time, like maybe every week, so that I can get my packages updated. So I think in general, it's a good idea to update your packages. But like there are two things you want to update for, actually three things you want to update for R. So one is R, the language, the other one is iStudio, and the last one is packages. And my advice, not exactly advice, my experience is it's a good idea to update packages in iStudio as frequently as possible. But when it comes to R, I want you to be a little bit like conservative. So like you don't want to be too behind, like 2 years behind, something like that. But you don't want to be like the most current as whatever, early adopter and so on. Because when R is updated, there are some problems unknown to the developer, and then you want to wait a little longer to see what are those problems, and then hopefully these problems are fixed. So for iStudio and packages, please update as frequently as possible. And for R, a little bit conservative about it. I think that's a good approach.
Perfect. Thank you so much, Dr. Kim.
Dr. Kim, I have some quick questions. I was trying to follow in the script, but I noticed some of the lines doesn't run. Like when we were talking about subset variables, I couldn't know the mSleep data set based on the script.
mSleep, okay. So did you run the this first one? Line number between 26 and 35.
Oh, okay.
Yeah. So if you didn't install and load these packages, because mSleep is coming from one of these packages, I think maybe tidyverse. So yeah. So if you didn't install and then load this tidyverse, then you cannot access to the mSleep data.
Oh, okay. I got it. Okay.
Yeah.
Okay. Now it's working. Thank you.
Good. Yeah. 21. Okay, I'm going to take a break and then see you in 4 minutes. And we are slightly behind, running out of time, not behind the schedule, but running out of time. But I'm trying to make the best use of the time we have for the rest of the session. Hopefully this is useful for your work, as you are working on your SICSS projects. So let me share the screen again. Everybody can see it. Then if you can see it, then please type 1 in the chat so that I can see we are all on the same page. Pretty good. Also, I want to sincerely thank you for your time and commitment, because I know that we have lots of Zoom time and Zoom fatigue is real. But hopefully, it could be useful later, and this is good investment. So the rest of the thing we need to cover is modeling and visualization. Before that, but I want to talk a little bit about grouping idea, because if you want to think of modeling and visualization, even before that, this is a kind of fundamental concept. So what is grouping? So the data I'm using here is a GameMinder. So GameMinder is basically world poverty data, so different nations and different countries and different years, and what's the observations about like their life expectancy, GDP per capita, and the stuff like that. So let me take a look at the data. There's a country, continent, year, life expectancy, year, population, GDP per cap, and so on. And here, what you want to do is, because this is huge data, and then just looking at the raw data is difficult for us to make sense of the data. So instead, what you want to do is summarizing it. You can think about summarizing is like a way to reduce many observations to some like single number or statistics that tell us about key information about the data we have. And what you want to do is calculating mean value of GDP per capita by continent. Okay, so if that's what you want, the first step you need to do is define what is the grouping variable by using group by function. And then you need to define what is the summarizing information by using summarize. And then, okay, I'm going to summarize by mean, creating mean statistics. And I'm going to save this information to a variable named mean GDP. So if I do that, I'm going to have two variables. One is this grouping variable. The other one is this summarizing variable. So we have only one summarizing variable. So that's why we have two variables. And this group by is actually also based on like one principle called split, apply, combine. So tidy data principle is very well known, but this is split, apply, combine principle is not very well known. But this is like a pretty fundamental technique applied in like many different, like data science tasks. Like at the very beginning of the session yesterday, I talked about it in the cooking. There are kind of two big paradigms, like fast cooking, slow cooking, and then in the data programming world, that maybe that's functions and object. And then I talk about variety of objects like data, data types like vectors and lists and matrices and data frames. And I talked about a variety of functions, like just a function, there's a wrapper and there's a helper and so on. And then this split, apply, combine is not exactly about function, not exactly about object. It's about flow. It's about workflow. So like there are regions that we have like very cluttered or messy code or copy and pasted code. And one of the reasons is there's kind of inefficiency involved in the way we combine different steps that we do in a data work. So split, apply, and combine is a kind of framework that replaces that process. So let me think about this one again in a different way. So if you want to do so this is GameMinder. So this is GameMinder original data, and this is the output using group by and summarize. And this is very simple and very obvious. But actually, if you wanted to get the same output not using group by and summarize, and that's trying to do that, I don't know, using subset base size, then there's something, and then like you need to continent equal Africa. Okay, so Africa, and then you got a GDP per cap because that's the variable you're going to use, and then you're going to summarize, calculate the mean value of it, and then you're going to assign it to mean GDP Africa something. Okay, and then this is one, and then you're going to copy and paste it. What's going to be the second one? Second continent, maybe Americas. So you're going to change it to Americas, and then going to change it America. So that's what you're going to do. So you're going to split data by this subset, and then you're going to apply it particular function that's going to be mean. And then you're going to create a bunch of new objects, subset data like mean GDP Africa, mean GDP America, mean GDP Asia, mean GDP Europe, mean GDP Oceania. So 5 new objects. And then later, maybe you need to do something like, I don't know, either merge it or bind it, whatever. So that's what you're going to do. Okay, so if you didn't use group by and summarize, these are the steps actually involved. These are the things that you need to do. But if you know this group by and summarize, it's just the 2 lines. You don't need to split, apply, and combine them together. Why? Because when you're selecting group by, you decide what's going to be, how the data is going to be splitted. So data is going to be splitted based on the unique values of this particular variable. That's how the data is going to be subsetted. And then this function defines what kind of function is going to be applied to particular variable that you're choosing for summarizing. And then based on this grouping variable, these all subset data is going to be combined together. So we didn't see this each process when you're writing down this this code, but actually behind the scene, this is what happened: split and apply, and then combine all these things together. So this split, apply, combine framework is like, you don't need to understand that. You need to actually, you don't need to aware of that. But this is what's happening behind the scene, behind this grouping variable. And this is so powerful framework that's used in other areas as well. So that's what I emphasize here. And then you can easily add other summarizing information you want to have in your output. So let's say now on the mean value, you want to have the count. You can use just the n function. And now you have 3 variables. So grouping variable, mean GDP, and then count. So how many observations in Africa, coming from Africa, how many observations that come from Americas and Asia, and so on. This is pretty cool. And then you can include other summary information based on like other statistics, some statistic information like the median, standard deviation, and so on, quantile, so measures of a spread, rank and position, count chain, and so on. That's pretty cool. And then I'm not going to talk about joining stuff, although it's very fundamental if you want to join different data frames. And I don't know like whether somebody going to talk about this during the 6th session. Like another cool thing developed these days is like you can use machine learning to link different databases. I think that's a pretty cool technique developed these days. So that's what another thing you might want to check out during the 6th. But I'm not going to talk about it here because that's a little bit advanced. Instead, what I want to focus in the rest of this session is modeling and joining. So we talked about grouping, but when I talk about modeling, there's another thing called I want you to pay attention. That's called nesting. So has anyone used the nest function in your work? So group by function is very powerful because it has the split, apply, combine framework behind. But there's another one that's pretty powerful called a nest. Okay, so yeah, Marisa does that. Pretty cool. And for other people, also, this is pretty cool because like it's gonna save lots of time. So if you believe the power of group by variable, function, you should also realize that how powerful nested function is. So the idea is pretty simple and straightforward. So group data is each row represents an observation. In the nested data, each row represents a group. And let me explain what I mean by that. So I still again using the GameMinder data. This is the GameMinder, just to refresh your memory. This is what the data looks like. This country, continent, year, life expectancy, population, and GDP per capita. And I'm going to group by country and continent and nested. And then you might not know what is what nested is, but if I did this and then show you the output, you're going to see what I mean by it. So let's add nest here. And now if you look at the data, the output is there are 2 grouping variables, and there is this like one new column called the data. And if you look at the data type, it's called list. Any guess what happened by using this function? What's nesting does? Any intuition, or those are people who used the nest function, can you explain what happened? Essentially, you have a list of data frames as a variable that you can rate on nest. Yes. So this is group data, and then you can, so let me just to pick one of these data frame, the first one. So if I do this, you can see that the rest of variables are nested into an observation, list of observations. That's what happened. And then you may wonder why this this could be useful, and I'm gonna show why it could be used, how it could be useful. So let's say what you want to do is like doing this, drawing this very simple linear model. So I'm gonna learn a regression based on these two variables, relationship between life expectancy and year. I just randomly pick up these two variables, and don't ask me why. I pick up these two variables, and then this is a function, and then it takes an argument called df. And if you have nastier data that looks like this, so two grouping variables and then data, now you can do something like this. So here is the if you look at this, mutate is creating a new variable, function for creating a new variable. So I'm creating a new variable called the mothers. And using a map, it's a higher order function. I'm going to explain what is a higher order function pretty soon. And then it takes the nasty column, the list column called data, and then applying this added model to this data. And then when I look at nasty, it has now a new column called mothers, obviously, because I used the mutate function. So it has data and then mothers. Wow, so data mothers, and what's good? So let's keep the suspense a little bit, and I'm going to show how it does. And if you look at the first one, nested mothers, the first one, this is the output. So let me take the data again. And then what happens here is we got a country and continent. We have data that matches to each continent and each continent and country. And these models, the observations here, are the linear model outputs based on this subset data. So this is maybe Asia and Afghanistan and Europe, Albania, and then what's the relationship between these particular two variables using the linear regression model. So if you want to do that, if you want to do that, the same thing using the space-R, then you need to do something like, I don't know, GameMinder. First, you need to subset data, and then you need to apply a linear model, and you need to combine again. But because there are 142 observations, what that means is you need to create 442 objects and apply functions to each of them, and then combine them. So that's too much. Instead, you can use this group by and nest and save your time. But this output is not very friendly because, like, if you look at this nested model, this is just a list output, so like not exactly useful. So you want to make this data presented in a data frame way. But how can you do that? Fortunately, first there is a package called the Broom that exactly does that for you. So I used Broom a function called glance from Broom package, and then apply this function to the observations in the mothers column. And then I create another column called grants. So now instead of list, now we have this nice output of the properties of the model. Yay. And you can actually visualize it. So you can visualize this output here. So this is continent and then I-square and a different country, and you see how I-square looks like across different continents. So the nice thing about this grouping and nesting framework is it's all based on the same principle, split, apply, and combine principle. And if there is like if the kind of work you want to do is like you need to think about scale. So I need to subset like data in like 100 different ways, and then I need to apply some functions. I need to combine them. Actually, you don't need to separate it. You don't need to split it. You just need to think about what is grouping variable, and then we need to do nesting. And if you are doing these things correctly, then you can save lots of time. Marissa, do you have a question?
Yes, so I'm still, one of the things I hope to get out of this is to be more efficient with the map function because it's such a time saver. Because I find myself nesting things just for easy storage, but I find myself always having to unnest because I have trouble of mapping and applying things. It just seems like for this example is a lot cleaner because you're applying it to, like, it's allowing it to choose the variables. But if I want to map something and apply a function to one specific variable, I have trouble passing on the arguments of that function onto map, which passes it on and maps to a specific variable, which gets super messy. So I can stick behind to talk about that more, but if that's going to be covered this week, then I'll just hold on to that thought.
Yeah, so that's exactly actually I'm going after this. So for this session, I think there are two. So we don't have much time, so I just want to pay attention to two things. So if you got a modeling output, like I said in the previous session, that's going to be the output format is going to be list. But sometimes you want to transform that the list output into a data frame, but that's a more familiar object when you want to visualize your output. So in that case, I recommend you check out this Bloom package because it has this glance function, tidy function that can help you to turn that list output into a data frame. But for the mapping one, so mapping is I think I have time to explain this. So mapping is basically a higher order function. And what I mean by higher order function is, so map takes, it's coming from the Perl package. And what map does is it takes either vector or list as an input. And then like let's say you got a list over this, like a first observation and then second observation. And then if you have a map, then you can apply this first argument going to be df, and then second argument is going to be whatever function you are using, so it's a particular function. And then this function is going to be applied to each observation in the vector or list. So that's what and then if it's data frame, it's going to be applied like a first column and second column and things like that, and so on. And map is and then if you think about Bayside, there's also like a similar framework called offline family, right? There's all L offline, V offline, stuff like that. But what's nice about map is the same thing. So it has more helper functions. So if you look at the Perl map, so this map is just like if you have only one variable, one argument for the function. Then you can use map. If you have two arguments, then you can use map two. You can have more than 3 arguments, then you can use a P map. And sometimes you want to change the output format, then you can use map. So maybe not list as an output, maybe data frame, then you can use map df. Sometimes you want to have some conditions, couple conditions for the variables you are choosing, then you can use map add. Sometimes you can think about, okay, I only apply this function to like numeric vector in the data frame. Then you can use map if. So one thing I don't have time to cover every detail about Perl function programming and then map, but there, if you look at the Perl and the map, there are just so many useful functions that you can take advantage for your work. So I know that this kind of doesn't fully answer, Marissa, your question, but it can give you some direction that you can further look into. Yeah. So Perl, if you remember, Perl is one of the packages that I strongly recommend if you want to step up your I game, because there are so many useful things that you can take advantage of. Okay, so let me just stop here because we are running out of time. And sorry for not able to cover the visualization part. But like if you want to get into this, I just cannot recommend enough this book by Kieran Healy's excellent book on data visualization. He's a social professor at Duke, and in my opinion, this book is one of the best one out there. So please check out this textbook on data visualization. It covers almost everything that I want to talk about data visualization. So I'm gonna stop here, but linger 10 minutes to respond to any questions that you have in mind. yeah, hopefully you find that learning R is less intimidating and actually it's fun. Yeah, I think I put all of this in the cloud folder, and then I gave the link to Nania, so she might be able to share the link with you guys in case you wanna review the materials. Also, I got a textbook, so you can check it out too, in case that's useful. The textbook is a little bit dense than this one. Let me take a look whether I shared. Yeah, so if you go back to the URL for the repository, and then if you take a look at the additional resources, you can see the link for my textbook. It's a still working version, so there are typos and some other usual shortcomings, but they might have for you to see other information. Also, I'm still updating it. There are many things I want to add to the textbook, but like I just don't have time for the other project. But hopefully, I can make it better by this year. It has been kind of my pandemic project.
I have a question. It's not really related to, I guess, R specifically, but if we have data that is, let's say, like a JSON data, and we want to basically get it into a data frame so that we can analyze it for all the other functions that are in R. Is there an easy way to do that, or should we just find a way to analyze lists?
There's a package called a tidy.json.
Oh, okay. Okay.
Yeah, so it takes JSON as an input and then turn it into data frame.
Okay, thank you.
Yeah, yeah. So usually if you got the data from like a Twitter API, that's JSON.
I still don't really get the nested part. Could you please do a brief recap? Like, what does the function do apart from adding another variable to the original data set?
Yeah, so it's like if you put nesting, let's say you got 5 columns. So maybe it's better just if I give you an example. With nest. Okay, so let me share my screen again, but we got 4 minutes. I don't know whether I can do that, but hopefully I can achieve the goal. So here we got the original data. It's not nested, but then we decided the first thing we need to do is deciding what are the grouping variables, and then we are going to rest. So another way you can think about this. So we first decide the grouping variables, and then the rest of the variables, so except these 2 variables, they are going to be nested into a column called data. So when you look at this new variable, okay, we got 2 grouping variables, and the rest of the variables kind of hidden or nested inside this column, data. So, and that's why this is a list, because this is actually a list of data frames. List of data frames. And why this is useful? Because when you are thinking about doing the subsetting, because you are trying to, I guess, doing something like, I don't know, game minder, and then create a subset data. This is what you are doing. Like you are doing country, Afghanistan, whatever, and then, you know, not country, yeah, country on the Afghanistan, and then continent, Asia, and then you are creating this, maybe you are naming it as like Afghanistan, Asia, and then do the same thing for the second one, and so on and so forth. And you are going to create like a, so because there are so many countries in the different continents, you're going to create more than 100, subset data. And if you're doing nesting, you just have one data column, and you just need to work with this column. That's it. You don't need to create like more than 150 whatever, columns, under columns, sorry, objects. So that's why I feel this is a much efficient way to deal with when you have like a scale problem. And then you need to, like, so basically, if you're just using base size, the problem you need to do really is like split and then apply and combine. So subset data and then apply some function and then combine them together. Actually, you can reduce that step using a group by and then nest function and then map function. So that's kind of new workflow that you can practice. And that's why I recommend it.
Thank you so much. This is really helpful.
Okay, it seems like we are running out of time, but I'd love to hear from you if you have any questions. I'm available on Slack, also email. And enjoy the rest of the SICSS and weekend. Bye, guys.
Thank you all for watching. For more information on SICSS-Howard Mathematica, visit our website, follow us on social media, and join our email list.